relevant to everyday life. Another week, another great episode for sure. And of course, my legendary icon and co host, Mr. Mark L. Christensen.
Hello, great to be here, Daniel. It's
Again,
another episode
yes,
of
another
Wonderful
great
Science.
definitely a beautiful, beautiful science indeed. Last week we talked about the bigger picture of biology, right? If I'm not mistaken.
Yes.
A great, great picture of biology.
Yes, I think so.
Mm-hmm. So
The
today, Mr.
bioscene.
Oh yeah, the bias scene. Definitely the bias scene. So today, Mr. Mark, what we will talk about today? What we gonna talk about?
Let's talk about how we humans today got our brain. Let's talk about the evolutionary process of how we achieved this wonderful machine that we use to talk and explore and discover life and enjoy life. Let's talk about that.
Interesting.
Okay.
Interesting choice.
Yes, didn't just arrive overnight. It was a long process to develop this organ, this organelle that has the synapses and the capability of taking today's information and technology and pushing it forward, which is really all that it does. And it does that as a collective brain, which means all the humans together do this all at the same time every day. So how did we get here? How do we get this machine? It's really fantastic to own it and to operate it, and it's a wonder on how we got here. And there's all these questions about the missing links of evolution, and that religion has a lot to do with it. But and that's wonderful thinking. But there's just a lot of evidence supporting the fact that it evolved into what it is today. And
Mm-hmm.
I like to start with the beginning, the beginning of all of biology. Since the human body is 100% biology, right?
Yes.
All of us are biologically evolved beings, right? So, how did we get here today with this biological growth supporting this brain is very interesting. In the beginning, there was bacteria, as we know, and this very originating bacteria was a prokaryota, meaning that it did not have a nucleus, or what I like to call a memory cell. After that, after probably a billion years, then the eukaryota, which is a cell that does have a nucleus. So somewhere in between there evolved a nucleus, and that nucleus basically gathers information that the cell can provide it, and mostly it is information that is from its membrane. And if you remember the little proteins that deliver these informations along these uh, little corridors to the memory cell, it's basically what they're doing is taking information from the outer membrane of this cell and delivering it to this nucleus, which is kind of the originating human brain, if I could say that, because that's all there was 3-4 billion years ago was this cell, and eventually it evolves, like we talked last time. It evolved into multicellular structures, and then animals that adapt to the environment that Earth is providing and that is constantly changing. So that adaptation is really important, and along with that is a brain capable of taking information from its exterior and using it to survive with and adapt with, kind of the same thing, in its ever-changing environment. So you have this memory cell basically, and it remembers all kinds of things. It remembers transportation, predators, and food sources primarily. So as this brain grows, it it evolves into larger animals, of course, adapting to those environments. And if those animals are larger, then the brain has to grow larger to contain more information so it can survive and adapt in that environment. So we have basically, if you want to look at oceanic animals, they are the beginning what would develop not only the spine, but a brain or even a head. And so the head started with crustaceans very early on. It developed in one animal. What is that animal's name? What is the name of that? Everybody knows it. I'm just spacing it out, but it is a crustacean, and probably the only crustacean that was crawling on the bottom of the ocean. Anyhow, that crustacean, I'll figure out the name. It developed the very first head. So that memory cell or nucleus developed into a section of the body that was separate from the body, and so you're beginning to have a separation of body and head, and an environment where that brain can grow, and a neck. So eventually that began to swim and turned into a fish, and the fish, of course, through surviving in its environment, needed to learn to think more, so it grew a bigger brain and a spine. It's very, 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 very important to think about the spine being absolutely fundamental to get a human brain. And we'll get to that. So as this fish is adapting to and surviving in its really cutthroat environment in the ocean, and even today, it's just, it's an environment that you can barely survive in for any length of time. And the flying fish is a good example of that, because that fish is alive because it had learned to fly for its short spurts, but the barracuda just gobbles that fish up so fast that it's learned to fly to get away from its predator. And that is an amazing example of the stride of evolution trying to survive and adapt. That flying fish is really amazing. So you have this aquatic life adapting to all different kinds of predators, food sources, and life. But the thing is that a fish brain cannot become intelligent because it doesn't get enough oxygen in the water. It does get its oxygen from the water, but only so much oxygen can be provided through its gills. So it's not going to really grow a complex thinking brain. So how does the human brain evolve and have all this oxygen? Well, it's going to take amphibious life, which is a fish adapting to land, which is outside of the ocean, and there's plenty of oxygen at this time for that animal to breathe and start to develop a more complex thinking brain because it is now fed with the proper amount of oxygen. Still on all fours is an important thing to realize. So that as reptilian life developed, it was able to survive in extreme environments again as this brain slowly gets bigger from fish to reptilian life forms. And this reptilian life form, obviously, as we know, grew massive to the point where nothing else could live but reptiles. And then, of course, the advent of the meteorite hitting in 65 million years ago was killed, pretty much all of the dominating reptilians at that time, so that mammalian life can now prosper. Now, this means that the brain had somewhere converted into warm-blooded animals to survive that kind of environment, because it's always adapting. This brain is always learning from its exterior sensors, feeding to constantly live in that today environment. So because the earth was cold for so long, the mammals, the warm-blooded animals that could survive in cold, really were able to dominate. And this gave way to the quadruped warm-blooded animal. Now, this is really an important stage to understand, because the brain is now feeding on different kinds of foods, and it's also evading different predators and surviving different climates. So the brain is having to find more room for synapses, processing, and memories, and also a big deal. But still, you weren't going to have a human brain evolve from a quadruped, a bear or a giraffe. it was never going to happen. And the reason why is because the brain in those animals needed to survive and feed are using their mouth a lot. And as you can tell, the head is forward, and the foramen magnum, or the spine enters the back of the skull, is coming out the side of the skull. And this is important to realize, that as long as that's the position of the spine entering the skull, it's always going to use its mouth and its jaws to feed, and therefore the brain will never sit on, say, like on a pole, like a human being stands erect. So the advent of Homo erectus allowed us to develop a much larger brain. So here's an important aspect to realize, is that the memory of time is extremely important if an animal is going to survive, project, and develop a civilization like humanity. And that part of the brain is the prefrontal cortex, which stores memory and time, basically. So the idea of time isn't even possible in a quadruped, because the brain isn't sitting upright enough to develop that prefrontal cortex. So eventually, when primates, which lived in trees for, millions of years, they lived by really three things. They kind of had four hands and a tail, five things, four hands and a tail. And they learned to adapt to that environment to survive and feed and reproduce. But once the grasslands came in and started to divide one tree from another and farther apart, that primate had to learn to sit on the ground and then run from one tree to another to survive, to feed and eat and reproduce. But the predators on the ground were the whole reason why the primates stayed in the trees. That's why they had a tail. They could survive there forever, because the predators on the ground couldn't get to them. But once the trees started to grow farther apart and the grasslands got bigger, they had to learn to run. And this is where primates lost their tail, because they were sitting on the ground so much and then running. And it's harder to run with a tail, obviously. Humans today have a tailbone, but it's the remnants of what that was millions of years ago. Okay, so here we are. We're now from quadruped to primates. We went from primates with a tail to primates without a tail. And then eventually this primate, and I think it was an isolated area, kind of like an oasis in a desert. That's what I'm thinking. And this oasis fed a jungle inside a desert. So this one particular primate couldn't run to the other jungles. It was isolated. And within that small fed jungle, as it became desert around it, that primate had to learn to run, walk, and use its hands. And that's how I think the human being became evolved from that primate into a human being. And that's why it seems like there's a missing link, because there's nothing on Earth today in between you and I and a chimpanzee or an orangutan. There's nothing. So we just think that there's this big missing link, but probably because of an oasis type adaptation through evolution, that we just got one species to become erect. Okay, so now that we're a standing monkey, our brain is able to finally grow hemispherically. And like I said earlier, the foramen magnum, where the neck enters the skull, is now underneath the skull, like going underneath, so it can balance it like on a pole. And this allows the brain to grow heterosphemically. That's not the right word. Like bulbous. So it has full range to grow in all areas. And this is when the prefrontal lobe started to grow. So once that prefrontal lobe started to grow, we recognized time, and we recognized ourselves as a being on the planet. And that is the short evolutionary version of how human brain got here, from bacteria to you and I so far. What's your take on that?
Interesting, interesting, Mr. Mark, and thank you for
Mhm.
sharing that information to us. So, what role
Mhm.
does curiosity play in expanding our brain capacity to unlocking new ideas, just like it's already full developed?
Well, it's always developing, so it's not fully developed really, but it's developed to its fullest to today. Um, and now that we have full use of the complete elements that make a mind wonder, uh, it, it it stimulates curiosity to fill in unanswered questions like why are we here? That's a pretty
Mm-hmm.
good one right there. And that question will probably really never be answered. Hopefully, because it's really the whole inertia behind self-esteem and feeling rewarded for having achieved things is that we don't know why we're here. Um, Now, the brain is still doing the same thing that it's always done, even since bacteria, which is taking external information from all of our senses and it's inputting them into a much larger computer, obviously, than a bacteria's memory cell. But it's doing the same thing. We're taking in information and we're generating new curiosities and new discoveries. And that's basically it's a very slow process. Uh, and we are thinking that the Devenians from, oh gosh, what are they, 14,000, 15,000 years ago? I'm not clear. I'm not totally correct on that date, but and Neanderthal too. They didn't see the Neanderthal is interesting. They didn't have a prefrontal lobe development. This lobe that's in the your head wasn't there. It was kind of like flat. So they were unable to really analyze time in a constructive manner. So that's just another growth element of anthropology and evolution to show that that part of the brain had to grow. So today we are still growing that part of the brain, and it's estimated that in 100 million years from today, which is not a lot really if you think about the whole time span of life so far, 4.5 billion, 100 million years, our foreheads are supposed to grow way out, huge foreheads to because that's the area of the brain that is curious and forever question answering and solving and also planning. So it's weird. It's like the more we know about our past, our present, and our future, that part of the brain has to grow to compensate for more and more information. So
Hmm.
if you can imagine, your grandchildren in 100 million years are going to have a pretty swollen forehead.
Swollen forehead. So,
So it's always
Mr.
growing.
Yes, always
It's
growing. Why is it
mhm.
we have a bigger brain than other, well, creatures on Earth?
Well, we have our brain is bigger because we're upright, first of all,
Hmm.
and we've just developed, century after century, we've developed technology. Think about that. That brain growth for a human cannot grow really without the next advent of an innovation or invention of technology, because that is the expansion of the brain. Um, Now they're saying that the Neanderthal brain was bigger, but it didn't have the portions of the brain that it needed to uh, solve complex problems, like I said earlier about time and future thinking. Um, and here's another interesting aspect: the dolphin used to be kind of a fox. on land.
Mm-hmm.
And because of its predators on land, it was forced to wade in the ocean knee deep for thousands of years and then neck deep for thousands of years. And then eventually just, to survive being eaten, basically. And it would
Mm-hmm.
probably run up on shore and eat and then come back into the water for thousands of years. And then finally the nostrils evolved up to the top of its head so it
Mm-hmm.
can completely evade those predators and go back into the ocean. This is like a reverse evolution, but what's great about it is that's the only fish that actually breathes human level oxygen. So that's why you can teach a porpoise great things, and they have great memories, and they can hear their names, they can count, because their brain uses oxygen. See, that's another weird thing. And whales is as well. They have oxygen, so their thinking is like almost, the level of a cow or a dog or an elephant on land because they breathe real oxygen. Um, but the reason why the human brain is so separate from every other animal is because it's had time to evolve, basically, and it's been and once again, you can't do it without technology. So once we had controlled fire as a species, 100,000 years ago, 200,000 years ago, once we had control, we can control fire. That became really the beginning of all the innovations because now you can protect yourself. You can manipulate metals. Metallurgy started early from fire, melting different rocks in your fire. They learned about glass, and these trigger your mind to make uses out of them. And this is really truly the true brain growth is discovering inventions and technologies that will stimulate your curiosity on what can be done. And really they strive from survival aspects, cold weather, predators, and planning ahead to grow food. And this is how the plow was invented, by the way. The Egyptians invented the plow. But if you didn't invent the plow, and if you weren't able to contain your own fires or start your own fires, as ancient man, you wouldn't really have any stimulus to become smarter. So I would say what's responsible for brain growth really in the human is technology. And unfortunately, because we're the only ones that have hands and fingers, we're the only animal that can build technology. But if you let a chimpanzee evolve long enough on its own and under certain conditions, by the way, not just where it lives, but those conditions have to change. But a chimpanzee in 1 million years from today could be fully standing and can learn to light its own fire. It eventually would. So that's one way of looking at why humans have such a different brain than most primates.
Well said, Mr. Mark. And what makes human brain
Mm-hmm.
unique compared to other animals, and how did evolution shape these differences?
Well, well, again, it's the environment and adapting to those environments and certain foods that cause the brain to want to survive those conditions. And it's totally adaptation. So the human brain is adapting to its environment today because of technologies that it's developed. And as you can tell, we don't have to we have to wear clothes because we don't have hair on our body anymore, at least most of us. And we also have dwellings and environments with modern heating and warm showers. I mean, these things are causing us to adapt to life differently because our environment is different than it was, say, 500 years ago. And I think the shower is only 100 years old. The warm shower, that is only 100 years old in our society. And I think that's pretty much only here in North America, not in South America, not in some African countries and Middle East. They don't even know what a warm shower is.
Hmm.
Uh,
Hmm.
that's just one tidbit. But if we're constantly adapting to our environment, today that's all the animals actually ever doing. It's just trying to adapt to the conditions that it's living in: hunger, shelter, and predation. Um, and you can't develop technologies when you're not standing on 2 feet. So any other animal that's not standing on 2 feet, and I don't mean ostriches or even a kangaroo. A kangaroo has 3 legs, by the way. It's a tail acts as a leg. So, and a bird, it's a teeter-totter, on 2 legs, yes, but it's a teeter-totter, so it has a tail and a neck. So it's actually 4 things that make that a bipedal animal. It's not considered bipedal. But if you don't 100% stand on your legs on 2 feet as a bipedal animal, you're never going to have the free hands necessary to build the technologies to change your current conditions, to adapt to them, like a warm shower, heating and air conditioning, and a roof over your head. And so we're adapting to these modern technologies that we've invented, and it's changing us. And it is prolonging human life at the same time. But so back to the basics here. If you're not a bipedal animal, you're never going to use your thumb and finger to develop technologies. And that's the difference between any other animal and a human being.
Well said, Mr. Mark. Well said indeed. And, well, to wrap up our discussion for today, how does human brain continue to evolve in response to modern technology and changing environments?
Yes, let's project a little bit here. Let's think about let's go to the end of the Biocene again, where eventually our Earth is going to heat up all this biology, and it will slowly decay until there is no more biology at all. It'll just slowly go away. It'll take 100 million years, but that's that is scheduled. That's the math even says that that this biology is going to go away. So, what does the human brain do to survive and adapt to its new and changing environment? And since that's the picture where we're headed, well, then the answer to your question is that we have to slowly, very slowly, adapt to that depreciating environment, and I call it the necrobiocene, which is death, slow death of everything biological. And to do that, the answer is we have to become very enthusiastic about new technologies, because really the big picture is that's what I think the Biocene is really about. It's about generating one animal capable of developing the technologies to survive the necrobiocene. Kind of like a plan. If I could say it like it seems designed like that would be the purpose for everything, the purpose for all biology, to see if that biology can survive what we're going to throw at it, which is the end of its birthplace. We give it a birthplace, we let it evolve, and then we to a point where it realizes that if there's an end to its birthplace, and then it tries to survive by adapting to a new environment, which is space. Of course, we went from ocean to land to sky, and eventually it will be space with a big forehead.
With the big four, the forehead, definitely. Well, interesting topic,
Yes.
Mr. Mark. Thank you for enlightening us, and I hope we will continue this topic because it's so broad that we need to talk about again. What do you think?
Yes, and be inspired as a human to be enthusiastic about adapting to our future.
Adapting our future is something else. So, Mr. Mark, would you like to plug in something?
Sure, yes. I'm the author of Fungus Theory of Conscious Growth. Here's my book cover right here. You find it at my website, marklchristiansen.com. and there's a lot of reviews there on the book. And basically, it is a collective of all the evidence showing that all biology has a true purpose to survive the end of our own planet. And remember, science, everything is science and is one science, all for the growth of a consciousness in a cold, dark vacuum that we call the universe.
Well said, Mr. Mark. And well, people, let's connect with Mr. Mark and let's support him with the book itself. Who knows, there's a more books like this to rise. So, Mr. Mark, thank you so much for your time.
Yes, Daniel. Thank you, Daniel. I'll see you next week.
See you next week. Mark, people, see you soon.